Good morning, class 8. Myself, Ranjit Kumar. I welcome you all in the e-learning program of Modern English School, Kunti Nagar, Nevada. This is the sixth video lecture of the chapter sound. Means in recent videos we were discussing characteristic of the sound. So in that, the first we have discussed loudness. What is loudness? Loudness is a characteristic of the sound that enable us to distinguish between a loud and a feeble sound, although the both sound have same pitch. So means loudness enable us to distinguish between a loud sound from a feeble sound, although both have same pitch. This thing we have discussed. We have also discussed that the loudness depends upon the amplitude. What is amplitude? Maximum displacement of the vibrating body from its resting position is called amplitude. To understand this, there is an activity in your book. I will discuss that activity here. See, take a stand like this. This is the stand, and place anything hard, means any stick or anything, attach it like this, and with the help of thread you attach a small lightweight ball. Any ball, small ball, it should be lightweight, बहुत भारी नहीं होना चाहिए. You can say, you can take thermocol or anything which should be lighter, ज़्यादा हल्का, मतलब हल्का होना चाहिए, वो भारी नहीं होना चाहिए. And now place a glass close to this. Place a glass, steel glass, close to it. Make sure that it should not be very close, means it should be just touching the wall of the glass. You should make sure that this ball, hanging ball, it should just touch the wall of the glass. Strike the glass slowly. You will see this ball will move little bit, and you will see a soft sound, not too heavy sound. Strike it hard. At that time you will see this ball vibrates to longer distance. It means when you strike it hardly, then the walls of the glass vibrated more, and more vibration means louder the sound, means more vibration, more amplitude, and so louder will be the sound, and this ball will move to a longer distance. Means with this activity we can say, if vibration is less, means less vibration, means if amplitude is small, then the ball, there will be softer sound, and if the amplitude is more, then it will be louder sound. So with this activity we came to know that loudness depend upon the amplitude of the vibrating body. Here this glass ball is the vibrating body. If it is vibrating slowly, this ball will move to slow, little bit far away from the glass. But if it is vibrating fast, means it is vibrating for long. Vibration is, if amplitude is more, then this ball will travel to longer distance. Okay, so these loudness we have discussed, and we have discussed loudness depend upon the amplitude, and its unit is decibel. We have discussed pitch. Pitch depends upon the frequency, and its unit is hertz. Okay, these two things is already discussed. Today we have to discuss this quality. What is quality? It is the characteristic of sound that enables us to distinguish two sound with same loudness and same pitch, means it is the characteristic of the sound that enable us to distinguish two sound with same loudness and same pitch. Means the loudness of the sound and the pitch of the sound is same. For example, take a guitar and a sitar. You take a guitar and a sitar. What you do, you set it that both produces same, the loudness of the sound produced by both guitar and sitar is same, and you set that pitch is also same. Still you can distinguish that this sound is coming from guitar and this sound is coming from sitar. So this characteristic, means this is called quality, means quality of the sound enable us to distinguish two sound although the loudness and the pitch of the sound is same, right? So it is the characteristic of that enable us to distinguish two sound with same loudness and pitch. It depends upon the wave form. Okay, now you just remember this, you don't have to do anything with this wave form. Okay, one more thing, what I have told just now, quality help to distinguish sound of sitar from guitar, although the pitch and loudness is same. Okay, this is the example. Okay, in yesterday's class someone asked me wave. Okay, a disturbance or oscillation that travels through a medium transporting energy from one place to another without transport of matter is called wave. To understand this, take a thread. Okay, एक रस्सी ले लीजिए, उस रस्सी में आप यहाँ होल्ड किए हैं, you mark a point here, okay, and you mark a point here. Hold the string like this and tell your friend to hold it from here. You give a jerk like this, so this rope will start moving like this. It will appear that this is traveling in this direction, this is traveling in this direction, but is it so? No, it is not so, because when you stop the jerking, you stop that, you will see that this point is still at the same distance. Means when you are doing like this, a wave was moving like this, it seems that the rope is moving in this direction. But is the rope moving? No. When you stop this point was still at the same distance. it means matter is not traveling, only energy is traveling, and that loop that you have seen, that is called wave. Okay, the disturbance or the oscillation that travel through a medium transporting energy from one place to another without transport of matter is called wave. One more example I can give you. Take one, there is a take a water body, take a water tub, and in this water is there. Place a floating ball here, okay, and do one thing. You note down the place where the ball is, and you drop a stone here. When you will drop the water, it will form a ripple. वो तरंग, that ripple will be formed, and you will see that water is moving like this, means it is moving outwards. चारों तरफ फैल रहा है. It is outwards. After some time, when ripples stop, you will see that ball is still at the same location. Ball is not traveling, means only the energy is traveling, not the ball. So waves are of two types: transverse wave. What is transverse wave? When the oscillation is perpendicular to the, when oscillation of molecule is perpendicular to the direction of movement of wave energy. You remember that rope you have done like this? When you done like this, what happens? This loop of the rope first come down, then same loop goes up, and this loop which was above, which loop came down, and this loop which was down, it has came up and it has came down, and this is the middle position, mean position. So this loop keep on moving up and down. So the wave is moving in this direction, and the molecule, this thread, is moving in this direction. So such wave is called transverse wave. Example: waves in water, in string and light wave. These all are the example of the transverse wave. Next is longitudinal wave. Longitudinal wave. If oscillation of matter is same in same direction of wave, direction of movement of wave energy. What I am saying, take a long spring, it is coiled like this, right? What you do, give a jerk like this. This is a spring, and ये sling, you know, तो बच्चे खेलते हैं, वो बहुत सारा coil प्लास्टिक का रहता है, that is called sling. Imagine a spring is there. If you press it here, press it like this, 1, 2, 3, 4 times, what happens? The first portion of the string will compress and the next portion will expand, means वो फैलेगा. उसके बाद क्या होगा? जब ये फैलेगा तो ये सिकुड़ेगा, और जब ये सिकुड़ेगा तो ये फैलेगा. मतलब this type of movement, the oscillation is in this direction. Imagine एक स्प्रिंग है, इस स्प्रिंग को ऐसे ऐसे अगर हम करते हैं तो मूवमेंट जो है इसी डायरेक्शन में होगा, और वेव भी इसी डायरेक्शन में मूव कर रहा है, तो इसको कहेंगे हम लोग This is called longitudinal wave. Example, sound wave. Okay. Thank you for the day.
Hi guys, today I just want to show you a demonstration of transverse and longitudinal waves using a slinky. Now, transverse waves, the direction of energy is going to be going forwards, and that's the same with longitudinal waves as well. The energy is going to go this way. But with a transverse wave, the medium, so in our case the slinky, which is what the wave is going to travel through, is going to be moving perpendicular to the direction of energy transfer. So let me give this a go. So you can see the pulses or the waves are moving from the left to the right. So the energy is moving from the left to the right, but the actual slinky itself is moving perpendicular to the direction. Now another kind of wave is a longitudinal wave. Now with a longitudinal wave, the medium, again which is the slinky, moves in the same direction as the energy transfer. So the energy is moving in this direction, our wave is going to be, or the medium, the slinky, is also going to be moving in this direction. So this is a longitudinal wave, like sound is also a longitudinal wave. So in this case you can see that there's a part where the wave gets compressed and a part where the wave gets rarefied, and that these pulses move along in the same direction that the energy is flowing. So that's a longitudinal wave, like that. That's a transverse wave. Okay, bye for now.